Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 12, Section 6, Locus. So, locus is a set of points, and it is locus, not locus, which is the little bugs that are coming out around here. So, a locus is a set of points, all of which meet a stated condition. To sketch a locus, draw all the points in the locus until you see a pattern. So there's two types we're going to do. We're going to do them in a plane, which means on a two-dimensional surface, and then also in space. And the locus will look a little different. We ask you to sometimes draw them, sometimes describe them, or we might give you a description and then you have to draw what it would be. The biggest mistake I see with this with students is make sure you're as specific as possible. If you say, a point, make sure you tell me where the point is. If it's a circle, make sure if you can tell me what the radius is, you do. So the first one we have is draw and describe the locus in a plane, the point's 1 centimeter from a given point C. So I'm going to draw a point C. And then what I'll do is I'll draw all the points 1 centimeter away. You don't have to get out a ruler and measure it. So these are all about 1 centimeter away. And pretty quick you can see what we're going to get is a circle. So once you get an idea of your locus, you just draw it. And then I'll put a little 1 centimeter right there, so to show that the radius is 1. So if I describe this, I would say a circle centered at C with a radius of 1 centimeter. Okay. So if I was grading this, if you didn't tell me it was centered at C, you'd lose points. If you didn't tell me the radius was 1, you would lose points. If you just said it's a circle, you'd get very few of the points. Okay, the second one is, in a plane, the point's 1 centimeter from a segment AB. So let me draw a segment AB. And 1 centimeter away, so this would be 1 centimeter away, 1 centimeter away. We'd also have points down here 1 centimeter away. And then also, so right here on the sides, you can see that what we're going to get is some pretty straight segments that are parallel to AB and 1 centimeter away. And then once we get to the endpoints, what's going to happen is we're going to get 2 semicircles, 1 on each side. So these are all the points. So this would be 1 centimeter, and then also the radius is here and here would be 1 centimeter. So to describe this, if you wanted to call it a pill-like thing, that's fine. So it's a pill-like figure, but don't stop there. What I need to know is the sides that are parallel to AB and 1 centimeter away, and 2 semicircles centered at A and B with radius 1 centimeter. Now the next one we're going to do together because it's one of those ones that has a really neat thing that kind of happens with it. So in a plane, the point's equidistant from 2 lines K and M, and 5 centimeters from the point where K and M intersect. So this locus actually has 2 parts. We have 2 lines K and M. All we know about them is they do intersect. So I'll just draw 2 lines that do intersect. So maybe we'll call this K, and this will be M. The easiest thing to do with this is to take the 2 parts of the locus, equidistant from 2 lines K and M, and the second part, which is 5 centimeters, and draw each of those, and then you're going to take whatever conditions meet both of them, so you're going to have a little overlap. Okay, so we'll finish this one in class, but at least get an idea of what you think it's going to be. Okay, next we're going to move on to space. So for this one we have describe the locus and draw it, the points that are C units away from point D. So we have point D, and we have all the points that are C units away. Well, in the two-dimensional, that's going to be a circle, but because this is three-dimensional, we're also going to get all the points that come out of the page and go underneath the page, so we're going to get it as a sphere. So I'm going to draw that the radius is C. So a sphere centered at D with a radius of C. And the last one we have, draw and describe the locus in space, the points that are 3 centimeters from line L. So if this is line L, I want all the points that are 3 centimeters away. Well, if you look in, again, the two-dimensional, what we would get is there's going to be a line up here that's 3 centimeters away. There's going to be a line down here that's 3 centimeters away. But we also have lines that would be above the page, below the page, 3 centimeters off to the side. So what we're going to end up getting is something that looks like a cylinder. So, but the thing about this cylinder is it has no bases. It's endless. So it's going to go on forever and ever. So for this one, I'm going to call this an endless cylinder. Centered at line L and with a radius of 3 centimeters. And that's it for today's notes. Thank you for watching. Have a great day.